So today we're going to be talking about some additional key characteristics in our graphing quadratics unit. We've talked about identifying our vertex, our maximum value, our axis of symmetry, our y-intercept, but now we're going to be really emphasizing the idea of our x-intercept. So what we've done in the past, right, when we are solving these quadratics, we are finding the x-intercept. So we'll take our function, this f of x is equal to 3x squared plus 5x plus 2, and set it equal to 0. This should look super duper familiar to our previous unit when we solve these quadratics, right? So we're looking to factor. We're looking to find the two numbers that multiply to that 3x squared, that goes in that first spot in both those parentheses, and then we test our outers and inners. So we get to that 5x. Totally big throwback, but a good throwback to get into this day after our long spring break. Okay, so now that we have factored this correctly, right, just testing our outers and inners, our inners add to the 5x, and then our two numbers, 1 and 2, multiply to 2. We know we factored correctly, so we'll set each of those parentheses equal to 0 and solve. So we get 3x plus 2 equals 0, and then x plus 1 is equal to 0. So our two solutions are negative 2/3 and negative 1. When we write those two solutions, those roots, we write it as an x-intercept, or as that ordered pair, x and then y. What we can take away from our beginning portion of this unit with our y-intercept, our y-intercept is written as 0, a number. So we can plug in that number of 0 into our function. I kind of gave you guys a spoiler already. When we solve and simplify that, we'll get our y value is equal to 2. So when your input is 0, that output is 2. So what we just found were our solutions, aka our x-intercepts. This is what I had you guys find when in our previous unit when I said solve, right, the quadratic. These are our solutions. You'll also see them identified as roots or zeros. And then the y-intercept is easily identified by looking at the c value, right? The constant, that number that's added or subtracted at the end of that function. Okay, talking a little bit more about our solutions, we technically have three different types of solutions in this quadratic. If our graph of a quadratic function has two x-intercepts, right, then it will have two solutions, two roots, two zeros. If the graph of our quadratic function has one x-intercept, then it'll look like that middle graph and it will have one solution. And if it has no x-intercepts, then that function is not crossing that x-axis at all. It will have 0 solutions. Technically imaginary solutions, but we're not going to get into that within Algebra 1. Okay, so now that we know some background about our x-intercepts, let's take a look at our quadratic function now. And again, we've probably seen this function in the past, but we're going to apply our x-intercepts or those solutions to our key characteristics. So we're using our axis of symmetry, we're using our vertex, we're using now our x-intercepts, our y-intercepts to create a graph of this function. So let's start with what we know about this lovely parabola is this y is equal to negative 6x plus 5. We'll start with our axis of symmetry formula because that will help us determine that line of reflection and the x value of our vertex. So to find that axis of symmetry, it's negative b over 2a. b is negative 6, so I'm going to do the opposite of b all over 2 times 1. And again, going back, we know a is 1, b is negative 6, and c is 5. Let's simplify that. We get 6 over 2. We know that x is equal to 3. So our axis of symmetry is 3 and the x value of our vertex. So I'm going to graph that axis of symmetry right off the bat. And then go back to graph that vertex. So we know the x value of our vertex is 3. That's our input. Now let's find the output, the y value. We'll plug in 3 for x and then simplify. 9 minus 18 plus 5 is equal to -4. So our vertex, right, that maximum value or the minimum value is 3 and then -4. Awesome. Now we want to find our x-intercepts. Our x-intercepts are our solutions to this quadratic function, which means it will be x comma y. Our y is 0. X comma our y of 0. So looking back into our function, we're going to replace y with our 0 and then solve. So 0 is equal to x squared minus 6x plus 5. Going back to our factoring quadratics unit, we need to find two numbers that will multiply to our -5 or +5 and then add to our -6. X goes in the first spot in both those parentheses. Two numbers that multiply to 5 are 1 and 5, right? And we need to get to that -6. So we'll do -1, -5, and then set both equal to 0 to solve. We get x is equal to 1 and x is equal to 5. That's when our y is 0. So our two solutions, those x-intercepts, those roots, those zeros, are 1, 0 and 5, 0. So we'll graph those 2 points. Ready? 1, 0 and then 5, 0. Oops. 5, 0. Sorry about that. And then go and move on to your y-intercept. Your y-intercept is written as 0 comma number, and that number is always the constant, right? That value that's added to the end of that quadratic. So 0, 5 is our y-intercept. So 0, 5, we'll graph that. To find the symmetric point, we're going to count from our y-intercept to our axis of symmetry. So we're going to go from our y-intercept, 1, 2, 3, and then go 3 on the opposite side, 1, 2, 3. Again, it should be the same distance from your symmetric point to your axis of symmetry, y-intercept to your axis of symmetry. And then we have our 5 points. How great is that? We'll connect those dots, go straight up to our minimum value, and then right back up. So then the stuff on the left-hand side should be reflected with the stuff on the right-hand side. There we go. Oh, so I didn't write our symmetric point. Symmetric point would be that point of 6 and then 5. We know that this minimum or maximum value is indeed a minimum value because it's the smallest point on that graph, right? And our minimum value would be -4. Our domain is always, for all quadratics, from -infinity to +infinity. Our range is the y values that goes from the highest to the lowest, or lowest to the highest. So -4 is the lowest, and it includes that value all the way to +infinity. We're going to do one more on the opposite side together, and then I'll have you pause the video and try one on your own. So let's go ahead and flip over to the opposite side and get working on our next quadratic. All right, so we are going to go a little bit faster with this quadratic, but again, pause as needed. Let's start with our axis of symmetry. We're just going to identify what each of our A, B, and C values are, so it'll be easier when we plug these values into our formula. So axis of symmetry is the opposite of B, all over 2A. We simplify that, and we get our axis of symmetry as x is equal to -2, always writing it as that line. That's also the x value of that vertex, so we know that will be our input when we go to find our output, which is the y. So going back into our original function, we'll plug in -2 in for x, and then simplify. Oh boy, and we get that x value to be a -6, or y value to be a -16, which means I have to do some scaling on my graph. So I'll head over to the graph, and then I think the x value should be fine. We'll keep each of those units to be 1, but then each of the vertical units, right, those y values, let's go up by a value of 2. Okay, now going to graph, let's go ahead and graph that axis of symmetry at x is equal to -2. Creating that dotted line straight up and down, and then we'll go and plot that vertex. -2, and then down 16. 2, 4, 6, 8, 10, 12, 14, 16. Now diving into our x-intercepts, all we do is we replace the y to be equal to 0. So 0 is equal to x squared plus 4x minus 12, and then we look to factor. What two numbers multiply to -12 and add to +4, -6, or +6 and -2. Set both equal to 0, and we should get x is equal to -6 and x is equal to +2, writing those as ordered pairs. X, comma, y of 0, 2, comma, y of 0. And then we can graph those points. -6, 0, and then +2, 0. So here's at least 3 of those points. All right, so our y-intercept is written as 0, comma, that y value, which is really the c value of -12. So let's go ahead and plot that point so it'll be a little bit more helpful for us to find that symmetric point. Right, so that pink point is my y-intercept. To find the symmetric point, I'll go from my y-intercept to my axis of symmetry, 1, 2, and then 2 over onto the opposite side, right, just reflecting that point. So then that symmetric point of my y-intercept would be -4, comma, -12. That y value of my symmetric point stays consistent. The x value is the one that changes. So there's my parabola. I can connect all of those dots in that U shape, right? Making sure that we have arrows on both sides. There we go. And those are my 5 points when I'm graphing this parabola. Looking at this again, I have a minimum value because I have that smiley face, right? And my domain goes from -infinity to +infinity. My range goes from -16 to +infinity. Go ahead and try this next example. Go ahead and pause it, and then I'll go through it after you're done. All right, so these are the different key characteristics of your quadratic. Your vertex is the same as your x-intercept in this case. So technically you only have 3 points in this graph based off of your key features, which is fine. Your y-intercept and your symmetric point of your y-intercept create the other 2. In this case, you have a frowny face parabola because that a value is negative, so you have a maximum value. So if you got all these, awesome, good job. Give yourself a pat on the back. Go ahead and try your homework.